Welcome students. Today we are going to study the last topic of derivative, that is application of derivative. In this topic we have only one type of application in our syllabus, that is maxima and minima. First we will try to understand what is maxima and minima, and then we will see one or two problems on this topic, maxima and minima. So if a given function, you have already studied in function chapter, we denote function by f of x. So suppose a function is f of x, then for every function there is specific graph. Okay, so suppose for this just consider that a particular function which we are considering now has graph like this, which I have shown here. Suppose a function has graph like this, then all points which are at the peak, these points are called as, all these points are called as maxima for this function. So here I have shown many peak points for this function, and all these 4-5 points which we can see are all maxima for this particular function. And similarly, what is minima? Minima is this bottom point which we can see here for this function. So all these 4-5 points, bottom points, are called as minima for this function. So here you must understand one more thing, that a function can have more than one maxima point and all different maxima points. Similarly, function can have more than one minima point, and that too many different points as minima. Okay, and there may be many, not only one. So here you must understand the most important thing is, in general, whenever we see maximum value, it is only one value. But for function, whenever function is increasing like this, the peak point is called as maximum. After that point, the function should reduce, function should decrease its values, set of values. So like this. And for minima, function should decrease, and at certain point when function start increasing, so the bottom point is called as minima. Okay, so here then now we are going to see how we are going to find maxima and minima for a particular function. So this is the method. Maxima is if a function for a function f of x, maximum value is f of a if f double dash a is less than 0, and a minima is a function f of x will have minimum value f of a if f double dash a is greater than 0. Now what is this f double dash? So in derivative, first exercise we have already seen that if function is denoted by f of x, here I have written f of x, then its derivative is also denoted by f dash x. Okay, and if you differentiate twice a function, if you differentiate twice, then it is double dash, f double dash a. Okay, so it may be confusing for first time. Now we will see an example solved on this topic, and then it will be much easier to understand. Okay, here I have explained 3 steps you have to follow. First, suppose this f of x, this is given question, f of x. Then if you want to find maxima and minima for this f of x, then first step, number one is you have to first find derivative f dash x. Then you have to consider it is to be equal to 0, and by solving this expression you will get x equal to a value. That value is called as extreme value. This is our step 1. So first, before finding maxima minima, we are going to get extreme value, and Then after finding f dash x, we are going to find f double dash x. Double dash is derivative of f dash x. Okay, so then we have to substitute the point x equal to a in double dash f double dash a. If f double dash a is greater than 0, then by definition it is said to be f of a as minima, not maxima. Now you may think that if greater than equal to 0, then why we are calling it as minima? And here for last sentence is, if f double dash a is less than 0, then f of a is maxima. But this is the definition. This is not f of a, this is f double dash a. So you must understand this, that to find maximum value for a function f of x, f double dash a should be greater than 0, and sorry, for maxima it should be less than 0, and for finding minimum value, f double dash a should be greater than 0. Now we will see one problem on this topic. So question is, find extreme value, maxima and minima for f of x equal to this x cube minus 9x square plus 24x. So f of x is equal to this is the given question. Now first we find f dash x, that is derivative using x raised to n formula. This is very simple. So find derivative. After finding first derivative, we find second derivative f double dash x. This is 6x minus 18. Derivative of x is 1 and 24 is constant, therefore derivative of 24 will be 0. So after finding these two derivative, as I have already told you, our first step is we have to find f dash x equal to 0. You have to solve this expression to find extreme value, that is a. So here we have to consider this f dash x here. Let f dash x equal to 0. That you have to consider. This is not given. We have to consider f dash x equal to 0. So here we are getting a quadratic equation. Here 3 can be taken common from this expression. So we get x square minus 6x plus 8 equal to 0. So this is the quadratic equation, and you know how to factorize quadratic equation. The factorization is x minus 4 multiplied by x minus 2 equal to 0. And now we can find value for x. So if x minus 4 is 0, then x will be 4. And if x minus 2 will be 0, then x will be 4. Okay. If x minus 2 is 0, then x will be 2. So this is our first step to find extreme value by solving this expression f dash x equal to 0, and we have found these values x equal to 4 and x equal to 2. These two values are called as extreme value. Okay, this is first part is over. Now we are going to find maxima and minima. So we don't know now that for x equal to 4 whether it is maxima or minima. So for that we have to come here, we have to put x equal to 4 in double dash, that is second order derivative, and if it is greater than 0, then f of a will be minimum. So now we have found here f double dash x. Okay, that is 6x minus 18. Now we are going to put x equal to 4 in 6x minus 18. 6x minus 18. Okay, so substitute x equal to 4 in this expression. So it is 6 multiplied by 4 minus 18. 24 minus 18, this is 6. So value is 6, and 6 is greater than 0. Okay, 6 is greater than 0. So if f double dash x, if f double dash x is greater than 0, that means f of 4 will be minimum for this function, not maximum. Okay, so to find minimum value for this function, we have to put this 4 in function f of a. Okay, not f double dash a. Double dash a will only tell you whether it is maxima or minima. Now we have to put this x equal to 4 in function f of x, and f of x is given in the question. Our question is f of x. F of x is x cube minus 9x square plus 24. So substitute this x equal to 4 in this equation, we get 16 value. So our minimum value, that is called also called as minima, is equal to 16. Now as we have found x equal to 2 also, so both of these are extreme values. Now similar process we are going to do for x equal to 2. So for x equal to 2, as we have done for x equal to 4, similarly first we will substitute x equal to 2 in f double dash 2, sorry, x double dash x. What is f double dash x? That is 6x minus 18. So substituting x equal to 2 in this 6 minus 6 multiplied by 2 minus 18, this is equal to minus 6, and minus 6, therefore it is negative value. So that means f of 2 will be maximum value. So now we will find maximum value by substituting 2 in the function f of x given in this question, and this value now we have found here, it is equal to 20. So maximum value is 20 in this equation. Okay, so once again I am telling you here the method, which I have shown here, the steps. First step is find derivative of f of x. F of x is given question. Then x equal to, after solving f dash x equal to 0, whatever values you will get, those values you have to consider as extreme values. Okay, those extreme values you have to substitute in f double dash x, that is second derivative of f of x. Substitute in f double dash a. If it is greater than 0, then f of a is minimum value. Now we have to note here that our maximum as well as minimum value are going to be, if you substitute this a in function f of x, that is our final answer. We have to substitute these values a, whatever set of values we are getting, in function f of x. So the final step must be substituting these values in f of x. So in next video I am going to solve another problem, similar problem. Thank you.